Thanks for joining me on Fascinating Frontiers, episode 68, coming to you on May 11th, 2026. Starting the week with the latest from space and science. Two space agencies just finalized plans to study an asteroid that will skim Earth in 2029, offering a rare close-up of a potentially hazardous object. The European Space Agency and the Japan Aerospace Exploration Agency have signed a formal agreement to study asteroid Apophis during its 2029 Earth flyby. The collaboration combines European imaging systems with Japanese spectrometers to gather detailed measurements of the asteroid's surface and internal structure. Scientists expect these instruments to reveal surface composition and any internal voids that could influence how the body responds to tidal forces during the close approach. The flyby itself acts as a natural experiment in asteroid dynamics, one that ground-based telescopes simply cannot replicate at this level of detail. This partnership highlights how international cooperation can unlock observations unavailable from any single agency or facility on its own. The measurements should help clarify how such objects behave under gravitational stress in ways previous missions have not fully captured. Now, on a completely different note, engineers are shaping the design for a new near-Earth asteroid detection telescope. This instrument aims to spot smaller objects earlier than current survey systems allow. It builds directly on the limitations of existing telescopes that often miss faint or fast-moving bodies until they are relatively close. Improved early warning lead times would give more preparation time for any future objects on potential collision courses with Earth. The design phase focuses on refining detection sensitivity without requiring entirely new infrastructure from the ground up. Such a telescope represents a practical step toward closing gaps in our ability to catalog the full population of near-Earth objects. From this rare close encounter, we turn to efforts that could spot such objects even earlier. Astronomers have identified a vast halo of stars and dark matter surrounding the well-known Sombrero Galaxy. The discovery helps map the galaxy's full extent and its interactions with surrounding space beyond the familiar bright disk. This enormous envelope extends the true scale of the galaxy much farther than optical images alone suggest. Understanding these halos provides clues about how galaxies grow and merge over cosmic time. The detection adds to our picture of galactic structure by showing material that would otherwise remain invisible to standard observations. While we refine our ability to find asteroids, astronomers are also mapping the full scale of entire galaxies. Journalists can tour the Plato exoplanet hunting spacecraft in its clean room at ESTEC on 20th May. The visit offers a final look at the satellite before it moves toward launch preparations and integration. Plato represents the next major European mission dedicated to finding and characterizing planets around other stars. The clean room tour gives media a direct view of the hardware in its final pre-launch configuration. This step brings the mission closer to deployment and the science operations that will follow. From mapping galaxies, we shift to visitors that cross between them. Researchers in China have built a dedicated system to study embryo development under space conditions. The work supports future deep space exploration by examining how biological processes adapt beyond Earth. Microgravity environments present unique challenges for cellular growth and development that this facility is designed to investigate. Such studies form part of the broader effort to understand what long-duration spaceflight means for living organisms. The system provides a controlled platform for experiments that could inform life support requirements on future missions. Interstellar travelers remind us how little we know about biology beyond Earth, which brings us to new orbital experiments. Scientists have pinpointed the origin of the latest interstellar comet to a cold, isolated part of our galaxy. The finding comes from detailed orbital analysis that traces the object's path back through millions of years of gravitational encounters. If the Milky Way were scaled to the size of North America, most stars would sit within a few city blocks of each other, while the sparse outer regions would stretch across entire provinces. An interstellar comet begins its journey in one of those thinly populated zones where gravitational nudges from passing stars or the galaxy's overall rotation slowly alter its path over millions of years. It then coasts through the vast emptiness between stellar neighborhoods at speeds around 30 kilometers per second, relative to our Sun. When it finally enters the inner solar system, its trajectory becomes a precise record of every gravitational encounter it experienced along the way. Yet astronomers still cannot explain why some of these visitors show unexpected activity, such as sudden brightening or fragmentation, at distances where sunlight should be too weak to drive such changes. You know what is fascinating about this? The comet's long journey turns the solar system into a kind of cosmic archive that records the galaxy's gravitational history in real time. Asteroid 13 Egeria offers a good viewing opportunity tonight as it travels through Virgo at 10th magnitude. Observers can track its steady movement across the constellation after sunset with modest equipment. The object provides a reliable target for amateur astronomers looking to practice their skills on a known solar system body. Its predictable path makes it an accessible entry point for those new to following asteroids from the ground. From backyard viewing, we close with one more profile bridging space and policy. Experiments are testing how alfalfa responds to watering systems designed for microgravity. The research explores crop viability for long-duration space missions where fresh food production becomes essential. Understanding irrigation behavior in orbit could determine whether certain plants can serve as reliable staples on extended journeys. These trials add practical data to the growing body of knowledge about sustaining crews far from Earth. While Europe prepares its next exoplanet mission, other nations are testing life support systems in orbit. Before we go, keep an eye on the upcoming media tour of the Plato spacecraft as final pre-launch preparations continue. That covers today's space and science news. Share this with a fellow space enthusiast if you found it interesting. I'm Patrick in Vancouver. See you tomorrow. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own. Drifting